The next speaker, titled Bringing Security in Tuakiri to Next Level, Vlad.
Good afternoon, everyone. Thanks for coming. Thanks to the program committee for putting me right first. Not sure how I deserve it, but yeah, thanks for coming. And in my talk, I'll do an overview of what's new in Tuakiri, and the overall theme is stepping up the security. So just as an overall overview, Tuakiri is the Research Education Identity Federation for New Zealand. It's been around since 2011, so over a decade. And since 2015, it's being operated by REANNZ, where I work. And I was with Tuakiri even before I moved to REANNZ, so that's a long relationship. And currently, Tuakiri has 17 member institutions, all of the 8 universities, 6 of the Crown Research Institutes, and I hope to get the last remaining one on soon. 2 smaller research organizations, and I hope to see more of them in Tuakiri soon. And 1 polytechnic / part of the Pukenga, and it's a tricky landscape, so I don't know what I can expect there, but again, extending the reach of Tuakiri would be great. Tuakiri is also part of EduGain, which can be called the Federation of Federations, and it connects over 80 similar federations from around the world. Tuakiri had a lengthy process of getting in. If you look at the dates here, we signed the paperwork in 2013, and then we spent a number of years thinking about how to do the policy side right. The technical part was easy, but since 2019, we are connected to Tuakiri, and for member organizations, it's on an opt-in basis. So you need to tell us you want to be connected to EduGain. We are suggesting you do tell us, but it's up to you to make that step. And 15 out of 19 identity providers are connected, so 3/4 of the way there. If it seems to you weird that I'm using the number 19 here and I had 17 on the previous slide, it's because I don't count us REANNZ and our virtual home organization as members of Tuakiri. That would be inflating it. But out of the 19 in total, 15 are in EduGain. So that means users from these organizations can access services operated by other federations and exposed to EduGain. We currently are not exposing any service to EduGain. For things that are collaborations just within New Zealand, it would not make sense to do. There are services which I think could possibly benefit from exposing them to EduGain. I might point to the NeSI projects portal as something where it would make sense, so that project collaborators who are from outside New Zealand and have an account at another institution connected to EduGain could access that directly instead of needing an account on the virtual home. But I understand it would be a complex project to make that switch, so just suggesting. And overall, if you would like to connect to EduGain, please talk to us, not just the royal we, but REANNZ. And yeah, we would be happy to get you into EduGain. Right now, it's over 5,000 institutions and available to access New Zealand services if needed. And we are exposing about over 500 services to our New Zealand EduGain members. So many services like various collaborations and even license portal operated from Mencl are available only via EduGain. Many publishers are shifting to, we don't want to register into every federation on Earth. We want to register just into one, get to EduGain, and everyone reaches us via EduGain. So all of our institutions should get there as identity providers. So the 15 should become 19 and match the number of IDPs in the federation. Just a look at what's happening behind the scenes. Tuakiri is operated primarily on software developed by the Australian Access Federation, our partner federation in Australia. And their software stack has significantly evolved. They've replaced some of the core components and merged them together. And that's a change that's ahead of us and work for me and my colleagues at REANNZ to make it happen. Not much impacting you, but you may notice some change. You may notice that Federation Registry got replaced by something called Federation Manager. So this will be happening. Expect some change. Otherwise, not much impact for you. But looking overall at the value that Tuakiri is delivering, very bluntly, you can say a Tuakiri login passes attributes about the user. That's been working for the 10 plus years. That's great, it's been useful. But in the current setting, more is needed to deliver the value that a Research and Education Federation should deliver to the sector. And 3 specific themes I have in mind and what I'm hearing, what other federations are doing is multi-factor authentication, attribute assurance, and security incident response. So for the multi-factor authentication, it would be about actually using multi-factor authentication on the IDP and communicating that MFA is required and was used. For the assurance framework, it would be that each member organization and the IDP would signal how sure they are with the identity of the user. And then there is a security incident response framework. I'll get to all of those in more detail shortly, but they are all results of collaboration by a consortium called REFEDS, which is a group of research and education federations. That's what the acronym comes from. So looking at MFA in more detail, there are 2 parts to it. And one is actually authenticating the user with MFA when the user authenticates at the IDP server. And that would be by means specific to the IDP. But an equally important part is being able to communicate about MFA. So service providers could request this authentication needs MFA, and then the IDP should be able to confirm, yes, we did MFA. And what happens on the IDP very much depends on what's available to the organization and what technology they use for MFA. Some institutions used to use Duo, and IDP used to support that with a Duo plugin that would kick in as part of the authentication flow, and after the user confirms the username and password, it would also initiate a separate flow for Duo. Because of changes that Duo introduced, that plugin needed significant rework. But my understanding is most Tuakiri members use Azure AD and have multi-factor authentication built into Azure AD. So in that case, the most straightforward solution is actually to use the Azure AD authentication. And that can be done by changing how the user authenticates, and instead of presenting a username password form served by the IDP, where getting the MFA in would be tricky, the IDP can redirect the user to Azure AD, which would be SAML proxying. The IDP would be also acting as a service provider in SAML, send the user to Azure AD acting as an upstream SAML identity provider, and receive the response, and translate it properly and send it back to the service provider. Those organizations on our hosted IDP solution are already using that. And for all of them, MFA is already enabled. You can also start using MFA this way even if you have your identity provider running on-prem. One member is already using it, and I've been in discussions with another member about possibly rolling it out. It's a configuration change that can be done. We can assist with that, and that can improve your security, plus unify the user experience instead of having users to know that sometimes I log in this way into Azure AD, or sometimes I enter username and password on a different form. It would be Azure AD login everywhere. There is a user experience change because Azure AD identifies users by email address, while the local login would be by username, so users would have to know suddenly I start typing in my full email address, but it would be consistent with they already do it anyway for the Azure AD login. And then the other part of supporting MFA in the federated context is communicating that MFA is required and that it happened. And in SAML, the protocol used for Tuakiri, is a thing called authentication context class reference, which is a string containing a URI-like value. And REANNZ have created a profile that says, if MFA happened, use this string. So on the Tuakiri website, we have documentation what needs to be done on a service provider to request the REANNZ MFA, and then to check that that actually happened. And on the IDP side, to map that between implementation-specific values and this generic value. So the beauty of it is each IDP, each technical solution would be using something else for calling MFA. Microsoft has a different URI specific to Microsoft, which ends with multiple authn, which they use to signal that Azure AD MFA happened. If you are using Azure AD for upstream login, you just map that to the REANNZ MFA, and the mapping happens both ways. We have documentation for it on the website. And if you go to docs, Tuakiri REANNZ, advanced concepts, MFA, you will find that. Or reach out, we would be happy to help you configure that. Thanks. The other improvement is the REANNZ assurance, attribute assurance framework. And it's about passing the correct values in the person assurance attribute, which should tell how sure are we the user really is who he claims to be. Did someone just fill an enrollment form without anyone citing the values, where the documents cited to a level? We used to define the values based on the NIST standard 863.1. That standard evolved through multiple iterations and grew and grew and grew and became unfit for the research and education environment. And recognizing that, REANNZ have created a simplified framework that targeting the RNE community. And it's now at version 2. And it has 3 components. One is being able to point to users and identify users properly in a reliably non-reassigned way. So J. Smith would always be just one person. If that person leaves and another John Smith joins, they won't get the same identifier. And I've been already in touch since last year about adding new user identifier attributes, some object ID, some supervised ID. They are the foundation for the first component of the REANNZ assurance framework. The second one is identity assurance, the actual has the user been checked. And the third one is should be easy for all Tuakiri members, and it's confirming that the attributes are fresh when expressing affiliation. So if someone is staff and leaves, the Tuakiri login should stop claiming that user is within staff. There are timing thresholds, but I believe the offboarding processes for this should work for most members. For the actual identity assurance, there are 2 approaches, both supported by the framework. One is process-based. The standard has about 20 pages. It has a number of points which you can tick, and if you tick sufficiently the critical ones, you can start claiming low, medium, and high, where low standard is just the baseline, like we support the framework, but we haven't done any work. No identity evidence is required. We just accept whatever comes in. Medium is, if I distill the long list of checkpoints to a single statement, is identity evidence appears to be genuine. So the user showed something that looks like a driver's license, and to the person checking it, it appeared genuine. And high is the evidence has been checked against authoritative database. This might not be supported at all institutions. You might not have processes that require that. That's all fine. There are services like National Institute of Health in the US that use Edugain login for getting to their services. And they verify, they may ask for certain data sets, we require users at medium. For certain data sets, we require users at high. Supporting just medium would get you quite far. For some use cases, high might be required, but that would be required just for select users, not for all staff across your organization. So having processes that support collecting the information on what checks have been done would be great. And yeah, that would be the building block. The other approach is risk-based instead of process-based. And that's like, are the identities trusted enough to access critical internal systems, even if you don't have documented processes, but you trust your own ways of doing things to let users to critical internal systems, you can claim that you have the enterprise assurance for accessing enterprise systems. So to support this, start thinking about what processes you have for proofing users, start recording the information and expose that information to your IDP, and then it should be quite easy to tick off low and medium, and maybe later do high. The security incident response framework is part of onboarding to Edugain. So those of you who are already in Edugain have been through it. There's a newer version that also requires federated, notifying federation partners. So if you have a breach, you don't deal with it just locally. You also reach out to your partner, to services that your users have accessed. So I may be touched about that. And just really last thing, sorry, there will be another round of IDP upgrades. The IDP version 5 is out. So if you feel like you've just finished version 4 upgrade, yes, 5 is coming, but it should be quite easy to upgrade.
All right,
and I'm done.
Yep, thank you. I'm sorry. If anything, I should have his back because he's REANNZ, but thank you so much, Vlad. That was very entertaining. I mean, it was very eye-opening, but I do have to introduce our next speaker. Thank you so much. Magically creating, updating research articles from experiments, and as we all know, Mark.
Kia ora. Good afternoon, everybody. My name is Mark Gahegan. I'm here to talk about possibly one of the futures of scientific publishing and how we can improve eResearch and the delivery of science. I was planning to speak in collaboration with my PhD student, Gus Alerm, who's done most of the implementation involved in this research. Gus is sick. He apologizes. He couldn't make it. Now we're all going to find out just how well the supervisor understands their students' work. Motivation. Traditional research journal articles are fossilized objects. They're stuck. They often contain errors, ambiguity, omissions, and they are completely disconnected from the originating scientific process. We know this. This disconnection leads to all kinds of unintentional consequences, errors in the published article or omissions. More than 90% of research is not reproducible from the paper that's published. Furthermore, papers are often out of date before they appear in print, or they become so really quickly afterwards when new data sets and new methods become available. Their technology is 450 years old, and it shows. A PDF is a poor container also. It's still a static thing. Jupyter notebooks are a little better because they encapsulate some of the code and data, but there's still a lot missing from the goal of making research reproducible, transparent, and live. So a question, what if research articles could be authored differently? What if conducting the experiment itself actually caused the article to be written? What if the article itself could be a digital container for all the research it describes? So instead of it being a PDF, it's actually a container that when you open it contains everything you need to know to reproduce, to understand, to validate the research that's contained within it. That's the goal here. So, you know, not a lofty goal at all, just a tiny little goal. The example shown here in this slide is our first live paper. It describes a vegetation response to climate data. It updates automatically as new satellite imagery becomes available. In fact, the figure that you see in the paper is not really a figure. It's an outcome of a complex distributed workflow embedded in a document. If you click on the figure in the document, you see a container. That digital container holds the workflow that created those maps. And it links to the workflow that provided the compute. And it links to the repository where the data was, and the repository where the results are published. The figure is actually entirely reproducible. If it weren't, you wouldn't see it. It's a programmatic artifact. It is not a dumb picture. So here we have two motivating questions. How can we link together all the steps in an analysis or in a workflow so that an experiment remains live? That is, it reacts to changes outside of itself. If better data becomes available or better code becomes available, the paper can update itself. Obviously, not all papers should update themselves, but many should. For example, if your research involves the state of a pandemic, a hot topic, has been of late, we would like the model to respond to the very latest data and probably also the very latest methods in order to predict what might happen next. The same is true if you live in a coastal community and you want to understand the impacts of climate change, or you're the government and you want to understand the impacts of the El Nino system on this year's harvest. We want the latest information. The latest information is available, but the latest information is not in our reports and it's not in our published research. That's the first point. The second is a more general question. To what extent can a research article be written and updated from such a workflow? Figures, code, data, tables are easier to update as things change, as data changes. But what about descriptions of code? What about descriptions of methods or descriptions of data? What about the literature review? What about the results and the conclusions? Can they be written as well or updated as well? Dum, dum, dum. 3 motivations for our work. First, we would like to keep published research up to date, live, so that it reflects the latest data, methods, and so on. Transparent, we would like that the research that is published is explainable and explorable by anyone who chooses to try and figure out what the researchers did. The workflow, the details should all be there. It should be explainable too. We should be able to close the gap between the workflows that create the science and the publication that you all might read, or some might read. The paper then becomes the interface for exploring the workflow and the data and the methods. It shows exactly what was done. And actually there's a fourth motivation too. We're lazy. We don't want to write research papers. We would prefer it if research papers could, to some extent at least, write themselves. The problem is that there is no container for the whole of the research process. It's a really complicated process. The question here is, could there be? Past approaches have tried to solve this problem by creating a digital environment that contains all the research tasks that we do in a single system. That's a massive task and one that's doomed to failure. Many people working in eScience over the years, including me, have tried to build such a system, an end-to-end system that encapsulates everything. It's just too difficult. Science is very hard to describe and hard to encapsulate. But this is changing. Containerization is now so advanced that we no longer need to create huge monolithic systems to make science reproducible. That's actually our working hypothesis. It's not a statement of fact necessarily yet. But when we look at the state of containerization, particularly as it applies in eScience, the richness with which we can describe the resources, the data sets, the methods, the workflows that we have, it's possible then, instead of trying to build a monolithic system, to link together a bunch of these containerizing systems using their APIs. And so this work doesn't re-implement anything. It just takes really good existing work and connects their APIs together. We use three specific technologies here. The first is Globus and Gladio to describe the workflow itself. This is in collaboration with Argonne Labs and with Ian Foster and his team. We've created a workflow system that supports reactive dependency-based computations to update a scientific paper. So it's like a little bit of customization of Globus in order that Globus will work for us to be able to capture these details of a research article as the workflow is being executed. The second container is the Research Object Crate, RO Crate. Has anyone heard of RO Crate? Yes, thank you, lady at the back. It's really humbling and very unnerving to have both the authors of Globus and RO Crate in the audience today as I'm giving this talk. Please do, thank you. RO Crate, if you know Winnie the Pooh, RO Crate is like a useful digital pot for putting things in. It's a general purpose container that allows you to describe a research object, could be some data, could be a method, a workflow, anything you like, with all the metadata that you might need to extract it and use it well. So essentially what we're doing is marrying those two technologies, along with a third one, which is Quarto, which is really a document layout and structuring tool, an authoring system that allows us to embed some of those research workflows into the document directly, so it becomes live. How do we do this? I'm going to have to speed up, I think. Look on the bottom line here. This is essentially a Globus workflow. It connects some data to some transfer action providers, a Globus term, and some more transfer action providers to the results. And in the middle here, we've got our own live publication action providers that encapsulate little bits of activity that are useful in research articles. They might be a table or a figure or a model that runs and produces some results. Those live action providers connect to something else we wrote. Whoops, wrong way. These live publication artifacts that sit in the layer above. This layer above is what sits in the Research Object Crate, or crates. So the Globus flow sits below. Parts of that are abstracted, useful stages in the workflow process are captured in these artifacts here. There's an orchestration server that sits above that orchestrates how this workflow works and puts the overall workflow into an orchestration crate, so the final result of all the workflow together is available here. But these live artifacts then get attached into the research paper itself, and they become reactive to the workflow, or they stay reactive to the workflow. That orchestration crate is a really quite interesting thing. It allows, RO crate as a technology allows nested crates. So one can have an entire workflow in a crate, but below that one can have a crate that holds the data, a crate that holds the methods and the code, a crate that holds the workflow. And so we've used that approach of nested RO crates to pull in all that information that we might need to recompute that workflow and then to surface up parts of it into our document. And again, too much information to give full details here. I have a video I can show. If you want more information afterwards, just tap me and I'll happily sit down with you. Above all this, there's a publication layer. And the publication layer, which is in Quarto, allows various aspects of these workflows to then find their way into a document. And because they're all connected back into a live workflow, if some trigger happens, some new event happens, some new data arrives, for example, we can trigger the recomputation of parts of that workflow and then the rewriting and republication of parts of the document and reversioning parts of the publication. You will see that there are various levels in which we can rewrite stuff in the Quarto environment, from changing just figures and tables through to changing text and variables that might otherwise be just dumb variables in the paper, but to connect them through to experiments. So the total impact of climate change in New Zealand for 2024 is, and in a traditional paper I would write a string. In a live paper, I would connect back to the outcome from a workflow, so that figure could change as new data comes in, as better methods get used. So in a simple case, in a programmatic article like the one we're building here, we can have variable text that's linked to the outcome of some process and stays live and connected to the outcome of that process. But we can do more than that. We can use generative AI, as Ian was saying earlier in his talk, and we can use it to generate narrative text for some of these objects. So if a code snippet or a workflow changes that you've described in the paper, we can use generative AI to change the description of it. And because code and workflows are context-free grammars in a computational sense, the likelihood of errors being introduced by a large language model is actually quite small. So in other words, I would argue that in this case, ChatGPT can do a good job in switching out your description of your code to a new one if the code is changed, if the code object changed while the paper is live. So we're now experimenting with using some of these large language model descriptions in our articles as part of the update. We're currently also exploring how to do that in an ethical way. And if you see those two examples here, this one here is a large language model used to describe a workflow object that is captured in an RO crate that is described using Globus. And this is a description of it created by AI. And on the right is a computer program. Yep, got it, thank you. That is also described directly from a large language model, ChatGPT, and embedded in the paper. It stays live. So to summarize, when all the steps in the process of analysis, from discovery and integration to method development and revision, to application, to final publication, when all of these are made reproducible and transparent, we close the gap between doing research and communicating research. And we don't have to write as much. Thank you.
Thank you for being on time. We're going to have little booklets out saying how many minutes each speaker has to go, in case they start looking our way, but there is a question.
Thank you for that. That was very interesting. Just curious, Since the publication is live and can change, how does somebody cite a particular version of it? And if so, if they cite a version, can you pull that old version back?
Absolutely, yes, of course. There would need to be changes in the versioning systems that are used by publishers. We have thought about that, and we have a solution that works for us for now, but the real trick would be getting a publisher to adopt it. Yeah, we would see, just as at the moment you have a version that was submitted and then a reversion that was published, we might have a revision that happened when a particular trigger event took place. And we might agree beforehand what those trigger events might be for a particular piece of work or for a particular journal. But I think that is part of the transformation process that has to occur once this is all working and being used, when it impacts the way we publish scientific research. So it's a great question. And we are working with one publisher right now to try and get them to adopt some of these ideas. We plan to try and publish a journal issue within the next couple of years that uses these ideas. So thank you, great question.
How would the live papers go with peer review?
Yeah, so you would peer review the version that was live at that particular time. It would have a particular stamp and metadata associated with it that says this is the version that went for review. Likewise, when it was published, it would have a new stamp that says this is the version of the paper that was initially published. And then later on, it would have another timestamp that said this is the version of the paper once the next year, 2024's data was available and we reran the analysis automatically. You can imagine that some of that would all happen automatically. You can also imagine that some of it might trigger intervention by a human to say, don't make a new version here or do make a new version there. It also gives you the capability to use that workflow yourself if you've got data, and then to publish your own version of the paper, like a mashup of my paper and your data.
Thank you for the talk. I really found it interesting that you talked about the motivations and that the researchers don't want to write as much. But maybe a counter argument to that is that the researchers do want to write a lot and publish a lot because that impacts on their career progression, HN index and all that sort of thing. So have you thought about that being the demotivator for something like that approach?
Yes, we have, but it's a great question, and I'm sure your view on that is just as valid as mine. There are a special case of research articles that go out of date really fast, and in fact, there are a lot of research articles that do, which means the value of the publication and the number of citations it gains is really small. For those people, this kind of technology is actually really useful because it keeps the paper useful for a much longer period of time. In fact, when communities have a norm where they build a model of something and then run it over many years, this actually will help researchers because their research will stay live longer. For example, if I work in genomics and I've come up with yet another method for genome alignment, my paper can be kept up to date because I swap in the new method. So I think, yeah, you might publish fewer papers, but the papers that you've had might form more of a longitudinal survey and be much more useful as artifacts over time. Take your point, though.
Thank you so much, Mark. Next topic will be NeSI's Flexible HPC, a journey through collaboration from Jun and Claire at NeSI. Thank you.
Kia ora koutou, ko Jun Huh tōku ingoa. Today I'm here with Claire Rai. We'll be talking about NeSI's Flexible HPC and our journey through collaboration. So I'll give a very brief background. What is Flexible HPC? So we started working on it in 2021. It's an infrastructure built to address more diverse needs beyond traditional HPC that might have been more scheduler, queue-based stuff, to being able to support more interactive or real-time, long-running various kinds of scenarios. And flexibility is in the name, but also built into the design. By that, we mean the hardware we design so that we can expand easily and also divide up as needed. And all of this is to enable us to be more collaborative. And underneath, at the bottom, we have the underlying infrastructure, which is like compute and storage network and all of that. All of that is possible through our partnership and providers, REANNZ, HPE, Mellanox, Cumulus. And on top of it, we have we've partnered with Stack HPC to provide OpenStack layer, which is providing access to those underlying infrastructure as a service. And this setup enables our users to have their own tenancy space on Flexi HPC, which lets you build research software and tools with full control while remaining secure from activities of other tenants. So I'll go over some of our key tenants and cover various forms of collaborations that we went through. One of our biggest partnerships yet is with eResearch, and we are working together to build their eResearch infrastructure. And this is an enabling platform underpinning all of their science. And this, they have been working together with us since the beginning of Flex HPC, and it's kind of developing an exemplar for the research sector by taking that risk with us. And hopefully many of the patterns that emerge from our collaboration can be applied to many other institutions. Thomas has given a talk on this. I was meant to point to his talk, but he's already given his talk at the other room. So I won't go into too much technical details, but it is essentially a very deep collaboration where this diagram, I won't go into too much details, but the green are the part that eResearch brought. So there's they brought their hardware as well as services that they had. We are building together as well, and the blue is the NeSI's on. So there's a whole lot of overlap there, and what we want to highlight is that the ways of working together, and we are building mutual support networks for both platform operations and user support, and both of us are discovering and learning about how best to support and develop a rich national eResearch ecosystem. And we are adopting agile processes such as running sprints and being very user-driven, user-focused. And there's biannual science spokesperson group meetings where we actually get to sit down with eResearch researchers and really learn about their experience. And now I will pass on to Claire.
Tēnā koutou katoa, ko ingarangi te whakapapa runga mai, nāri ko o Wairaka, te whenua tupu, kei Oriwa o I noho ana, ko Claire Aitokunga. Thank you for having me here today. So I'm going to, as Jun said, talk to a couple of collaborative projects that have utilised NeSI's flexible HPC platform. So the first of those is the Aotearoa Genomic Data Repository, or AGDR, and this is a repository for taonga species genomic data. So this was NeSI's probably really, I guess, first foray into effectively contracting out our software development capacity. And so sort of in collaboration with Genomics Aotearoa, who are leading on the project, and I've highlighted a couple of lines from the contract that really show, I guess, the approach of having shared goals within building this infrastructure and sort of shared accountability. Just highlighting the main team who have done all the hard mahi, and I just wanted to really focus on I guess, a particular aspect, so highlighting all the hard work that Ben Tiaika did while he was Vision Mātauranga for GA. And really this was about designing all the tikanga, the protocols around submission and access for how the genomic data repository would work, but also to ensure that the data remained onshore and within New Zealand from a sovereignty perspective, and really to allow the kaitiaki over the data to fulfil their responsibilities effectively. So this was an interesting challenge from a NeSI perspective, with regards to the open source software. Gen 3, which has been built out of Chicago, has, up until we got involved, only been deployed on AWS. When the project started, there was no AWS in New Zealand, and so we needed to bring that technology over to OpenStack in order to then deploy it within New Zealand. So I guess just again highlighting the sort of collaborative nature of working with the Gen 3 team in order to get that up and running. And I've just highlighted here a screenshot from one of the Gen 3 community forums where we were sharing back our developments for how we'd managed to do that deployment using Helm charts on the OpenStack infrastructure, with the idea of, I guess, moving forward as a community and being flexible in that way. So the other topic or project I want to talk about is Rakaora, which is a pathfinder in genomic medicine, and really took quite a co-led, co-development with Maori approach. And I think for NeSI was, again, a bit of a first in the way that collaboration worked, and really those key relationships and building those relationships was absolutely key. And I think it can be kind of, I guess, explained how this worked from the tikanga that was taken at sort of the initial approach to it. And the next slides are my colleague Helen Wihongi's, and I guess she normally talks to them in quite a specific use case for defining the researcher-participant relationship. But I think actually they go broader than that and quite eloquently kind of encapsulate the wider collaboration within this project. So, te tuku I te taonga, or sharing of the gift. So this is the idea that at the start you need to establish how that relationship is going to work. For us, this took really the leadership from our Maori stakeholders and group, and translating what that looked like into the infrastructure. And then testing that in terms of the running of the genomics and testing it, and feeding back in this sort of semi-agile looking loop. The next part, te hao o te taonga, so the using of the gift, the idea of, I guess in a research setting, how the data and the tissue is actually used. For us, this looked like, what are those overarching philosophies as we go through developing this infrastructure? And so these, and I won't go through all the specific tikanga attributes, but this was really a living part of the kaupapa that was led by Ben Tiaika, and Helen Wihongi and Hootie Watson and Phil Wilcox spent a long time with us looking at how we approach this, and looking at really these key principles that need to be built in from the start into the infrastructure, and what that looks like. And so one of the key ones I wanted to highlight really is the need to create transparency. So within every part of that infrastructure, there is transparency for those who have kaitiaki over the data that's being used, to see what's happening at any point, to look at the results, and of course things like logging and auditing from the perspective of coming back to look at it at a later time. And then so finally, te whakahoki o te tauanga, so the returning of the gift, and often that in a clinical sense or in a research sense is returning of unused tissue or samples. For us, this I guess is a screenshot of showing us feeding back results to the Ngāti Pro Oranga board, so in a hui that we had, and really engaging with them and hearing their feedback on those initial results. So I'll hand back to Jun now, but I just wanted to highlight really all the people involved in Rakaora who made this happen. Thank you.
Thank you, Claire. Now I'll talk briefly about another example, which is a slightly different kind, because we are hosting GPUs on Flexi HPC for Strong AI Lab, which is a research group based in University of Auckland. And they are kind of leaders in the sector, exploring new ways of doing AI research, trying to find impact on social impact, and they are very much experts in there. So we are giving them a little bit of under-the-hood access and letting them lead the design and optimization. And we are there to support and learn from watching. This is not a tenant, but we have recently launched last September Research Developer Cloud, which is the cloud layer access of Flexi HPC for RSCs to be able to come in as a tenant and access the system. I have a talk this Friday going into a bit more details here. Due to time constraints, I won't go into too much, but I'll give one example of an early access tenant, Manaki Whenua Landcare Research, who is Nick Spencer, I think I saw him before, yeah, who approached us with the mindset that he wants to bring cultural and paradigmatic shift in the organization, where tools are not built just in a siloed sense, but built with longer-term concerns in mind, so that there's more accessibility and so on. I'll delve into it a bit more in my talk on Friday. So where are we headed? With all the things that we built together, we want to catch up sort of common patterns, blueprints for solutions that applies widely. For example, we are in the process of building a blueprint for Kubernetes, which helps with scaling, robustness, and portability of applications hosted on it. And there are a few other examples here which will help you deploy your own instance of various solutions, such as a Globus endpoint and pipeline for your instrument using Globus, so on. In the future, we see researchers having access to various shared solutions and common tool chains that our collaborators and tenants build. And we want to make it as easy for RSCs to build and share beyond their own group and benefit the wider sector. We are also in the process of procurement of new HPC, and that will be our latest tenant on Flexi HPC. So we are kind of eating our own dog fooding, and we are now learning to collaborate across our own teams, which is very challenging, and we'll come out of this with lots of learnings that can be shared as well. Maybe lots of design patterns and that can be applied elsewhere. So where do you fit in this? We tried to paint a rough landscape today of where we are with Flexi HPC and how we are collaborating to support research communities. And we are very keen to learn about your use cases and possibilities of working together. Looping us back to the conference theme, he moana puke puke e kengia e te waka, navigating and evolving e-research landscape. Our journey has been made possible only through all the collaborations. And we started thinking about our responsibilities as an infrastructure provider, but we are also thinking about your responsibilities too, how you interact with your community, with researchers and users of the tools that you build. We want to leave you with not just good tools and technologies, but also good practices and ways of learning from and with your researchers. Thank you.
We are very lucky for our next speaker, Rasha Abu Safia from the University of Otago, to be talking about the Harmony in Progress, research lifecycle, maturity model, and digital transformation at the University of Otago. Thank you.
Kia ora, everyone. And I was so happy that there was the mini break between my speech and the previous speeches, or everyone would be just sleeping, fainting, and is it another conversation? Oh, but thank you. And I hope you had a fresh mind and perspective for this conversation. And I got my timer on, so I don't see all of the signs of you have just passed the time and everything. So I'm here today on behalf of the collective vision and efforts that we had at the University of Otago for many years, but especially during the past couple of years, when multiple teams from research and enterprise, the library team, the information technology services, had to have a pause and think is how we can figure out with all of the transformative efforts around the rapid changes in technology that is supporting researchers and our community, and at the same time with every new solution that our researchers needs to handle and to acknowledge and to work with, and as an institution, how we can look to that from a complexity lens in order to allow us to support our researchers. And as Mark said, is like to enable our researchers to do less work for the publication and to do more communication. We also think is how we can simplify our environment so our researchers can worry less about how to do their work and focus on doing their work in a very successful and thriving environment. But as I said, it's like I've been always thinking, what is our role at the university in order to enable our researchers, not to guide or drive them toward the rapid change toward how the technology is working, but how we can be the support vehicle in order to enable them. And this is like comes in a timely with all of the massive conversations around digital transformation and how we change the way we operate as an institution, moving from many different models from decentralized to centralized and back to decentralized, and how we can organize and work together as a collective team in order to move to the next vision. And as we can tell, with the rapid changes with technology, there will be always all of the vendors around us selling us new solutions. And with our academics and researchers like feeling fed up, it's like which technology to tool, where use, where's our data, how we can operate. We decided to pause, think, and have a collective approach that is mainly based on stakeholder engagement-centric approach as a team toward how we can support our community. So thanks on behalf of our team that has been ready with a collective vision, volunteer their ideas to see how we can work together. So how? It's like how we can support this piece of work in a massive way has been always behind, which will look like a piece of cake for researchers. Everyone knows the research life cycle, starting from the ideation to the planning to running the research, going to the publication and making it available out in public. But also we were thinking of how we can facilitate the strategic planning behind making the research become more successful and to drive it from a digital solution, digital excellence-wide, where digital and digital excellence actually is a driver and a supporter for our researchers community. What we have been thinking of is what do we have as a capability, not how the business process is moving, but how we actually support each and every different aspect of this capability. Although we have many people, but as you know, within a complex system like the University of Otago and other systems, you will see many of the people getting in and leaving. The knowledge move with them back and in. And each one of us has a different view toward how the system is running. And it's a fair understanding of the complexity lens that has been applied. So we decided to take that approach and to think about how our system is structured. We have been also looking to mapping the institutional research support services. Do we actually cover every single capability? Do we know the mechanisms to speak to each other and to understand how we can support in a collective way the work we are doing? And of course, my favorite thing is applying the complexity lens, how everything fit together or not to fit together and how we can integrate the different aspects. But it also flexibility versus the process flow. Is it's like the complexity in terms and in comparison to the simplicity approach. And also looking, are we doing well, not doing well? what we define and look like as an urgent priority. Is it the urgent priority, considering the rapid growth and it changes and lots of the strategic planning toward how the university vision is moving and how we can support researchers to do better? And last but not least, do we have the right tools, the right mechanisms, the right resources that support our community to thrive? As almost all the researchers know, nothing new in this one, but that was the driver behind where we should start. Actually, we should start from where the researchers will feel confident toward actually doing the research. We have started building our system having key 4 layers: the preparation, conducting, output, and outcome. And this is where we started to dive deep within each of these cycles. And I mean cycle because the start and the end is so dynamic. It depends on the research, depends on the resources, depends on the complexity, depends on how the many number of years people engaged and everything. So we have been always thinking that it's not just black and white image that we should look and consider as a team. But the very interesting aspect that we have been looking at is when we consider our support services that is really engaging in supporting how the research is happening, is do we have that right mechanism in what we are doing? So we have defined 7 domains of how the research support is happening in the university, looking to the grants management, and this will include internally funded, externally funded, partially funded from different resources, international fund, all of the different aspects of how we can manage financially with all of the complexity toward the documentation required to run. And do we have the right systems to do that? And then, of course, with every research aspect, there is a financial complexity. Do we have an ERB system that is so connected, easy for researchers to access the data, or they have to run the Excel sheet around a different system and to manage their financial flow and do the reporting and everything, which is so confusing and distracting from actually doing what they need to focus on, but to create that enable conditions. And of course, compliance management, and one of the key aspects is data management. Every research resulting data, where that data is stored, are we supporting it? Do we have the right, every single question? But as a team who have been jumped in that ship in order to see what we can do, was very critical to understand and to be honest, where do we stand? Do we have the right system? We don't have it or not? And of course, as a tech person, we'll always think about how the technology management, do we have the right software tool in each aspect for each capability for the support? The intellectual and proprietary management is a key aspect. And last but not least, which is also growing in a massive way, is the benefits management. Do we have the right structure in order to support that? And this is what we ended up, the research life cycle for Otago. And one of the key aspects, as you can see from the dimensions, it has the 4 layers, which represent the flow of how the research usually could happen, but also provide some flexibility toward having a start and end of each cycle and having a dynamic approach toward what exactly can happen. And with that conversation with our researchers community and research and enterprise and the library and everyone, we are trying to paint the picture toward what does the complex research lifecycle ecosystem at Otago look like? But also we were trying to dive deep to understand what exactly the key capability in each phase. So for example, within the preparation layer, we have 2 key cycles that either overlapping, minimized, expand, the different type of support available in. And in the ideation, for example, we have Maori consultation as one of the key aspects. And the questions we have been asking ourselves as the first keyword we started this morning about experiment. Do we doing it well? Who's supporting it? Do we have the right forms and mechanism? Do we have the right tool? Do we have the right system? Do our researchers, especially when we are looking forward for more researchers to engage with our community, do they know how to navigate the complexity of our environment to support them to do their work? And we have been also interested to understand the flow between the different capability. And as you can tell, with each capability, we were looking, what is our maturity level? Is it like with any maturity level? Is it actually a capability gap? We have nothing to support that capability, or it's capable, like initial, repeatable, defined, or a capable in that length and complexity aspect. But it was very important because as supporting the researchers, the more we understand how hard the life of doing the research, the more we will be able to enable and understand the complexity we are creating by offering a different tech tools all the time for the different pieces of work. So we have mapped the current state. Was very interesting with the actual and many hours of work among the team in order to be honest and place ourselves where we stand. Do we have that capability domain as a gap? Or do we have a specific capability that we have invested a lot of money and resources, and it has been well communicated, outspoken, that everyone by doing only this piece of work, then we have thrived our research landscape. That honest realization provided us with a good support toward how we design our initiatives and digital transformation initiatives, which is not just about the technology, it's about also changing how we operate as an institution and how our processes are structured. Was very interesting as well. In order to plan for the future, we have to look forward toward what is our next vision. So in order to thrive, how we can move each capability domain to the next level, what is required in order to run it. And I'm talking here about a massive level of information toward there's like a massive processes under each capability. We have a different support structure and a different team and different access to resources. And we are expecting like our researchers community just to grasp all of that at the same time and be ready to run the research. And then said, okay, if we're planning for a future state in 5 to 7 years from now, what areas that really has been left behind that will require us as an institution to focus our capability and move it to the next level. And as I said, as the key title of this presentation, it's a harmony in progress. It's a work in progress, because as we are taking this deeper breath, trying to get the focus, understand how we are operating, the institution is still running. There's lots of digital transformation initiatives happening, and new research projects are running, like access to our high-capacity storage needs to be managed and maintained, and our infrastructure support and everything. But it's always good to have that step back and a vision in order to scale up to the next level. But also, as we just don't operate in a small bubble as an institution, it was very important for us to look to the higher education business capability model and how do we compare toward the research lifecycle mapping and the different capabilities. So can we then communicate the common language toward which areas we are working, and we have done that mapping, looking to where we stand, and having that realization that, for example, as within the theme of this conference, we'll be talking about research data management and how that is a big, massive area where my colleague Wallace and the rest of the team will have some conversations around 4:30 if you're interested to know more about that, is how we can take that problem to the next level within collective efforts to solve it. But also it will enable us to understand that the right level of investment will be driven by the priority analysis that has been conducted and agreed in a collective approach. And as I said from the beginning, like digital transformation for me and as a person coming from the tech background was the key driver toward how we can take it to the next level. So once we have done the business, we understood how actually the landscape of the ecosystem is working, we have started the conversation toward the technology landscape. And that was a massive one for us, because each time you will ask anyone how many software tools or digital tools do we have, how they are integrated, less integrated, do we understand the harmony in between? But these are questions where we have started, and it was a massive data collection as well from every researchers and support, because with every capability, do we have the right tool? Do these tools integrated? Do our researchers actually know about the resources we have? How we can communicate these resources? And this will open a more flexible and a dynamic approach in order to communicate the information we know from support systems to the researchers community. And then the key question, what about AI? And do we have the right tools for the future? And how we can transform our current environment to the next level? And then how we can facilitate our researchers to access and utilize these tools. As just a general 2 examples, currently we have 2 key digital transformation initiatives running at Otago. The first one is the upgrade of the institutional repository system, our archive, and Kate is here, she'll be happy about this one. But the key aspect of it, do we understand how by placing just a new tool, how it is integrated within the life cycle? Are we running the right level of data integration to facilitate the process? And as you can tell, here it was so obvious for us as a team designing the business case behind that project that is actually involved between the experimental of the project, the publication, and the output. The output is the key aspect where the data will come in, but there is lots of integration with the HR system, finance system, connecting the researchers and making the life easy. And another key initiative under the leadership of Research and Enterprise, which is Otago Research Information System. And that is as well a full integrated and data lake concept, looking from the grants management process from the start to the end and how we can facilitate and integrate. And as you can tell, touch base with 3 cycles, but also overlap with the other cycles. And then when it comes to the answer, do our data lake facilitate our life to connect everything together? And the answer was, it's a harmony and progress. We're doing our best. We are working toward a better future for us and for our institution, but also more for our people and for our researcher community. So we are planning for a future, although digital and tech is the key aspect, but it's the enablers in order to allow our researchers to thrive. We are still working. We are still asking ourselves a question every day toward what could come next, how we can make it better. But believe me, with the collective vision and the team behind it, like the steps will be much more clearer and the vision will be much more closer to be achieved. Thank you.
Do we have one question?
Hi, thank you. I'm an academic, so I'm on the receiving end of this. My question would be, how do you plan, or do you plan at all to share this knowledge? Because I imagine that every university in New Zealand is looking at these things and wondering, and I'm just thinking that we don't want to be repeating the same thing over and over again, because that's a very expensive and intensive process you've been through. So what are your plans for sharing it?
I also have a note for that, just to let you know that all the universities actually do meet up. Wallace is also a part of that. We have a monthly catch-up with all the IT departments, networks, and to collaborate more. So that's something that REANNZ kind of put together last year, and it's still ongoing.
Yeah. And my answer is that we didn't reinvent the wheel. We have started from where other universities has done lots of collective efforts toward that one. So we have done to some universities in Australia and the States and here as well in order to build the model we are following. And definitely, the more we know, the more transferring that knowledge to the higher education ecosystem and other universities would be something we are looking forward to collaborate and work jointly in order to spread that knowledge, that it will be in favor for everyone. Because cracking the puzzle of how research can happen is not just an easy mission, but it will require the collective effort of a nation team behind it to make it work.